Just setting it up on YouTube. I have to redo it. What? How to close it? Just an escape. No problem. No, that's a good question. I've spent so long on that one time. I'll never forget. All right. Clap your hands once if you can hear my voice. Clap your hands 3 times if you can hear my voice. Clap your hands 2 times if you can hear my voice. Yes. All right. Good job. We got this. How did binary search go? Give me a thumbs up if you got it. Thumbs down if you didn't. Thumbs in the middle if it was going okay. All right. Yeah. Pretty good. Pretty interesting. Okay. Let's go through it together. All right. So first thing we got to do is what? Declare a function? Yeah, I know. You're like, 3 months in, when is he going to tell us? When is he just going to do it? Maybe soon. I'm going to call it bsearch because I'm a little lazy. And I'm going to say it takes in an array and a target. Okay, great. Let's say, okay, find a base case when the target is not in the array. What's a good base case? Someone I haven't heard from today would be really cool. Leo, yeah.
Let a middle index equal just define middle index.
Okay, it's not quite a base case. That sounds like the next step, which I'm into.
Array dot length equal to 0.
Okay, so when the array of length is 0, when there's an empty array, we can be pretty certain that the element's not in the array, right? Unless they're looking for nothing, which just wouldn't work programmatically. Okay, so we can say, hey, if array.length, yeah, I could do a bang. I'm going to be really explicit though, is equal to 0, let's return -1. Yes, sir.
Please explain again why you return -1.
Oh, it's just like, it's a standard thing. Yeah, like if you use index of, like one of the built-in JavaScript methods, it will return -1 if it's not in. Yeah, I mean, this is a little bit of like a dealer's choice. You could make it false. Might make things a little easier at first, but we are doing this -1 because we specify the directions and because it's kind of a standard index to return if it's not found. Crispina?
I'm going to talk to you about that later.
Okay, no worries. Okay, cool. So let's keep flying. So Leo said something about a middle index. Hey, we're going to need it. Let's do it. Let's say let mid index equal dot floor array dot length divided by 2. Anyone disagree with this? Feel something different with this? Or are we okay? Okay, cool. If you disagree with something that I write, or like don't understand it, or want to talk about it, like let's do it. Otherwise, I'll just kind of keep going. Okay, so what are the 3 possible situations here?
Oh, wait.
David.
So there was like a slight, not confusion, but remember when I was asking like the right side or the left side or whatever? If it's odd, right, which is having to pick the middle one, right? If it's even, I guess it doesn't matter if you go to the right or the left because there's no real middle.
Right.
Right. So it's like your choice. So if you really want to do the one here with like having an even number, be like on the right side, then on the left side, then you would do like already that like -1, right?
Yeah, that could work. Yeah.
You just wanna,
You wanted the other side, the other middle.
but since it doesn't.
Yeah. For those of you who couldn't understand, here he was saying when we have an even number, we got like two things in the middle, right? It's like my full name. I have an even number of names, so I always tell people I don't have a middle name. But I do. I have two, right? Not going into that, but I have them. And so he's saying the same thing. It's like, hey, you actually have two middles. You have to pick one. And I would, and he's saying it doesn't really matter which one you pick, right? And we could choose array.length divided by 2, or we could do array.length minus 1 divided by 2. You get the other middle. Yeah, fair game. Either middle is a middle name. Or you could say I don't have a middle name. Okay. So what are the three situations here? Max?
Target is equal, greater,
Middle element. Good. So Max says the three situations is we're going to look at that middle element, and it can either be the same, which in that case sounds like we're done. It could be smaller than, which means we got to go to the left, or it could be greater than, and we got to go to the right. So let's kind of start mapping these situations out. So if I say if array at mid-index is equal to our target. So this is in the event that that middle element is the same as the target. We're done, right? And we want to return the middle index, so we just go return mid-index. So this is like a perfect situation. If this is like the dream, like if the element was right in the middle, we'd be just done. Eventually we might hit it. I mean, eventually we'll have to hit it if it's in there. But the earlier, the nicer. Okay. Let's outline the next situation. Else if, I'll say array at mid index. So in the event that this is larger than the target, which side do we need to go? We gotta go left, right? Sounds good to me. So I'm gonna write return, because I'm gonna want the outcome of this no matter what, because my 0th index is always the 0th index. If I'm going left, it still matches up perfect. That's why I did this one first. To me, it's a little bit easier. I'm gonna say return bsearch of, and then I gotta get the left side, so I'm gonna do array.slice, and I'm gonna go from 0 to the mid index. I have a typo? I called it bsearch. Oh, haha. I also spelled it wrong. Thank you. You're an Uber guy too, right? These guys, these Uber drivers really can see well. Okay, like so impressed. Okay, all right, so we do return bsearch, array slice, that, and we also need to pass in the target, right? Takes in 2 arguments. We've now handled the left side. Okay so far? Okay. Let's talk about the right side. Let's talk about the exciting side. Else, I don't need to do else if. There's only one other possibility here. So instead of just returning this, because we can't just return it, because like we saw on the thing that Reed wrote, right? If I have the number 7 there, that's the number I'm looking for, and my first middle index is 2, which is the 6, and I go over and I return whatever comes from the right side, it's going to return a 0, right? Do we agree? Like, do we visually see that? When I call bsearch on the right side with the target of 7, it's going to return 0. So it's at the 0th index of that right side. Unfortunately, that's not the index we're looking for. We're looking for the index of 3. And we had the index of 2, in our mid. So we have to account for that. We're going to have to do something with that number eventually. So I'm going to set a variable. I'm going to say, hey, let result equal bsearch. And I'm going to pass in our right side. I'm going to say array.slice mid idx plus 1, because I don't want to include it. And I got to pass in the target. Okay, so as we go to the right side, eventually this will resolve to something. So if it was in that example up there, this eventually is going to become the number 0, if I'm looking for 7. Great. So now I need to make a check. I need to check. I definitely don't want to just add stuff. Like if this ends up being -1, right? Like oh, we're not.
Why did you add it?
Slice is inclusive. I've already checked our mid index.
But you're missing the 915 because it's exclusive on the.
But I've already checked our mid index here. No need to pass it on.
Oh, okay.
But I'm cutting it out when I go to the next side. Good question. So if my element wasn't in here, right? Let's have worst case scenario here. I've searched for the number 40. It's not in here. This was going to give us back a -1 eventually. This is going to evaluate eventually to a -1. Well, I wouldn't want to add our mid index to -1 because that would ruin it. So I can make a little check. I can say result not equal to -1.
Yeah, but that's equal.
Thank you. Uber. It's like unbelievable. Okay. Now I'm going to do this as a ternary. I'm going to say return. So if result is not equal to -1, I'm going to do something, which we'll think about in a second. Else, I'm going to be returning the -1. Or I guess I could, yeah. Okay? So what goes into something? That's the question.
Return the index of the collection at them. Do that?
Okay, good. So let's pretend this is the one on the board, and we've searched for the 7. We've gone to the right side, and this is evaluated to 0 because we're in that second column. Okay, great. We've got a 0, but we're in the second call. So the call before, we want to still keep track of where we were. And the call before that mid index was 2 when we had the 6. So I'm going to say mid index plus result. Okay, but now we're only at 3. Yeah, actually, we're still at 2. I'm sorry. We're at 0 plus 2, according to that. But we need the number 3. But the reason we're getting 1 shy is because 7 is 0 in the second call. But the real array doesn't have 2 zeros, 2 0 with indexes. The real array has only 1 0 with index. Yes, I'm going to hard code plus 1. It's not exactly like hard coding, but yeah, it's accounting for a pattern. So if we think of, we got to look at this example. I'll like circle it. So let's go over here. This is going to be kind of the key. So this is the mid index times that. This is the mid. This is the mid element, right? But the mid index is 0, 1, 2. Okay. We've called search for the number 7. And we've gone, okay, on our very first call, we ended up fitting it to 2, and we said, hey, is 6 less than or greater than 7? Right? Go, okay, 6 is less than. So we made a call with this. Just going to kind of shorten, okay, step, but more eventually it's going to check in the middle. And let's say where middle works and rounds down and it checks here, and we go, okay, this is the target at 0. So this eventually evaluates to 0, because this is at the 0th index of this array. Right? But 7 isn't really 0th index of the bigger picture. It's really 0, 1, 2, 3. We really want 3. 3 is the answer we're looking for, but we have 0. So we're adding 0 to the previous call's mid-index, 2. Right? So now we have 2. We're 1 away. Why are we 1 away? Well, in the real world array, we have 0, 1, 2, 3, 4, whatever. In new world arrays, we have 0, 1, 2, 0, 1, 2. It's an extra 0. We don't want that extra 0. Right? Because this isn't really the number 0. This is the index 0. This is the index of a value of 1. You have to think of the index 1 as like a value. So we had that extra 1 to cover this secret 0.
Is it alright if I do something really quick? Like, can you point to the mid index over there? Can you point to the mid index?
Which for
For the 6 is the mid index for the entire thing, right? That's that.
Oh, what's this? Number 2.
Okay, so the number 2, and then can you do the result? Like what it evaluated to? Yeah, that's the 0, and then we want to go 1 more. That's why we did the 1.
Yes.
I want to go 1 more. Yeah, just want
Me
to
too.
evaluate that to 1.
Right. We want the 0 to be 1, the 1 to be 2.
But not 1 more, that's not important.
7 is actually 1. Just think you both get it, just thinking about it different ways. That's fine. Any other, like, where is that 1 coming from?
Okay, so now in your result variable, you have a radar slice mid-index plus 1.
Yes.
So that's slicing from 7 to. Okay.
I didn't add a 1.
Depends on how you
Here, that is the numbers of rows, is the vertical also rows. You could get
database.
if you're in, you have a line,
Yeah.
your vertical is row and a certain line. Just,
But it'll keep cutting in half.
that's why it's.
That's why it's log. The difference between 20 items and 40 items is like twice as many columns. Just one more column. The difference between 80 items and 2. That's pretty substantial. Cool. Okay, so let's test it. See if it even works. Should work. Conceptually, it should work. All right, so let's try it out. Do B search. We have an array. Let's just do 10, 11, 12, 13, 14, 15, 16. So if I'm looking for the number 10, I run it. Oh, we're not going to be able to see anything. There we go. Shows up at the 0th index. Cool. I'm going to try something that's smaller than anything in there. -1. Excellent. Let's try something that's going to go to the other side. Let's try number 16. We get 6, 0, 1, 2, 3, 4, 5, 6. Looks good. And we'll try something that's bigger than anything in the array. And we get -1. Cool. Works. Okay, so what's yeah, thank you for the gentle applause. What's something that's kind of negative about this? Like what kind of sucks about this? Well, okay, yeah. He says negative. The -1 sucks. Sure. I'm thinking of something like more performancey. Yeah.
Compensating, what, the second, or anything after the first
What?
one.
Sorry.
Compensating is the zero.
Oh, having to compensate for the zeroth index. Sure. Someone could view that as sucking. What else? What else sucks? What operations? What do we think about? What does this do for the memory? What does this do for the time? What's faster? What's slower? Come on, let's talk about it. Leo.
How do you decide to put the array at the middle index equal to target at the first if statement?
Who decided that?
Yeah,
Me.
How do you decide it? You always want to the greater or smaller, and the bottom one is
That's fine. However you want to organize it, it's fine. That's no problem. Crispina?
Are you trying to talk about that we're solving it recursively?
Okay, so that's one thing that could potentially suck is that we are solving this recursively. And if it's so big, we might have a stack. You know, it creates more stack calls, and that takes up a little bit more memory. That's something that kind of sucks. Sure. What else? What else might suck? No idea? Any idea? How about slice? What's slice do? Slice, mutate, or copy an array? Slice copies. All right. So this is an extra array every single time. What's the time complexity of slice? O of n. Yeah. Right. I mean, we're only doing up to half, so like, it's not really that big of a deal. But we're adding up a bunch of space. So that's something to like be aware of, right? Being able to talk about these kinds of things and recognize these kinds of things is important. All right. Let's try to write a better one. We'll write it together. Most of this is, I'll just write it from scratch. Okay, so if we wrote const b search better, let's do some more stuff. So we're going to pass in an array and target.
Can you delete the other thing?
No, it's right there.
Can we log on thing?
What do you want to log?
You make the target 16.
I already did that one. It's 6. Okay, let's keep going. All right, so we got better b search. So taking an array and a target. So let's pretend we don't actually want to duplicate and make all these extra arrays, right? We could do this. We could do this with one array, right? Could we do this with one array?
Without splitting it up?
Yes. Without mutating the array, without splitting it up, what can we do? What can we do instead? Not an object.
Find the middle of 2 and 2.
Yeah, tell me more about that, Alex.
You find the middle, then you find the middle of that middle.
Yeah, sort of. Okay, so what Alex I think is like pushing towards here is right. We can have an array inside of an array with like using pointers. We can conceptually have an array. The array starts at 0, ends at its length, right? And then if we decide we wanted the left half, the array would still start at 0 and go up to that middle index, right? We could move these pointers. So let's kind of see what that might look like. So if we have pass in a start, And we could default it to 0 because we're not expecting our user to put this in, right? And so I'm going to default it to 0 so it starts with the whole array. And I'm going to add a stop, and I'm going to do array.length. Yeah, I spelled it wrong, but okay. Nah, I mean, we could, but we'll have to set something else. I'm just going to leave it as it is for now. But that's a good guess. Okay. I can expand it over here instead. Okay, so I'm passing in a bunch of junk, right? But the logic of the rest of the stuff still remains the same. I can check if, start off with this, and I'll say, hey, if our array.length is equal to 0, we're still going to run a return our -1. What else are we going to need? What's the next thing we need? Binary search? Yeah, a middle index, right? So we're going to say let mid index is math.floor. And we can say, this is going to get a little bit more tricky. What do we want our middle index to be? We can't make it array.length because the array's length is always going to be the same. And we want to be able to change our middle index. So what can we do? So this is going to be almost the same as the function before, right? So it's going to be recursive. It's going to keep calling middle index. But we're always going to pass in the same array. We're not going to be making extra arrays. We have these 4 variables available to us. And I'm saying, how are we going to determine our middle index? Because we can't just do math.floor array.length divided by 2, because arrays.length is always going to be the exact same. So what's a way around this? I could put stop. That's part of it. What about in the event that I go to the other direction? But you're on the right track. Let's see. Alex?
Can you do like start plus stop?
That's it. That's what I'm looking for. Right. So if I do start plus stop, this is divided by 2. Now I'm kind of in business because this is, so when start is 0 and array stop is array.length, we end up with the same thing. But if I go to the left side and our length gets smaller, right? Muna's right, we could still just use stop because our start is 1. But if we go to the right side and our start becomes the number 5 or something, we can't still just use the end if the end is 10 because now we only have an array of 5 to 10. So we would want 5 to 10 divided by 2. Okay? So we've got this middle index, minor adjustment, and then we could do pretty similar stuff. So we can say, hey, if array at mid index is equal to target, what do we want to return? Yeah, right. Okay. Mid index, right? I'll do an else if statement, and I'll say array at mid index is greater than target. So in the event that it's greater than target, what do we want to do? What do we think? Nilene? Yeah, exactly. We're going to redefine we're actually going to redefine what stop is. Because we want to go to the left side. But exactly, we're going to still do the return. We're still going to call b search better. And we're going to pass in that same array, that same target, that same start, because if we've gone to the left side, our start's still 0, but we got to change our stop. What's our stop going to be? It's almost mid-index. I'm hearing some people say mid-index. This is now the stop. Okay. Let's keep going. Else, well, I'm no going to be. I no longer need to check for this result because I'm doing it all the way, and it's either going to be -1 or it's going to be the right index. I also don't need to account for the mid-index anymore because it's the real array. We're dealing with real target numbers now. So instead, I can just do, I think, although I'm looking at my notes and I called the wrong function, so we'll see. We might have to do some debugging. B search better, array, target, mid, IDX, +1, because we want to change our start, and we'll do a stop. I think this should work. But I might actually be wrong because I'm realizing that my notes were wrong. So, interesting. Let's give it a shot. B search better with the numbers 16 here. Okay, we still got our 6. It's a good start. We'll try 10. Still got our 0. Looks like it's going to work. Try 13 in there. We get our 3. Excellent. I guess we should try things that are outside of the bounds. So this doesn't quite work because we're not changing the length of the array. We'll have to adjust for this. Right? This doesn't make sense anymore, our array at length. So we'll have to do something like if start is greater than or equal to stop, maybe. -1. 17. -1. Let's make sure the other things still work. Great. Everything still works. We just had to change the base case a little bit because our array's length wasn't getting smaller. Oh, good. My notes weren't that off. Crispina.
Can you explain the new base case that you made, sir? It's greater than equal to stop.
So when that happens, it means that we didn't find our element. So if we were looking for, if we had an array of 16 and that was it, something at that point, our start could be 1, 2, 3, 4, 5, 6, 7, or 6, right? Or it could be 6, and we'd have our stop be 7. I guess that would be, we would add it again, mid-index, it would call it again with the +1, and now our start would be 7, and our stop would be 7, and that means we didn't find it, so I'm returning -1. Good question. Yeah, do we see why this is better? I mean, it looks a little bit more confusing, sort of, but not totally to me. And maybe it makes more sense to you because we don't have to add that mysterious 1 and things like that because we're dealing with the same array. That's pretty exciting. That's a pretty big win.
Just to confirm, base case, return -1. That's kind of like a standard thing.
It's a standard thing for like trying to have something return an index of an array. If it's not there, it returns -1 for JavaScript. Not the standard for Ruby. Ruby's false. Yeah, we're not. Sure. Okay, we've got an array. 7, 8, 9, 10, 11. What number do you want to look for? 10? I heard a 10. Let's do 10. Something harder. They're all around the same.
That's 12.
10 is not in there.
I was looking at my numbers.
Johnny, sorry to decide. You're doing 10. Love the enthusiasm. Okay, our target 10. Our start starts off at 0. Our stop is what? 5? Is that? I'm going to trust you. Okay. 4. Oh no, but we did the length. We did the length, so you're right. It's fine. I'm going to continue to trust you because you were right. And okay, we do our mid index. Start plus stop. 2.5 rounds down to 2, right? So we'll have mid IDX is 2, and we'll check our array. We'll say 0, 1, 2. That's a 9. Is 9 greater than 10? No. There's like a kind of a big pause there. No, 9 is definitely not greater than 10. So we are going to be doing our else statement. So we're going to be returning whatever comes from this next call. And that's going to be passing in an array. Target, same. Our mid index. Now our start here is now what value? 3, right. 2 plus 1 is 3. That would be the element. Yeah. And then our stop is what? It's still the number 5. Right? These are indices. Okay, we've called the search. We have to come up with a mid index here. So mid IDX, 3 plus 5, 8. 5 by 2 is 4. Our mid index is now 4. And we can go at 4 here. So 0, 1, 2, 3, 4. Okay, we're at 11. We say, hey, is 11 greater than our target? It is greater than our target, right? So we're going to go on to our line 28 and return whatever comes from this one. And we say, all right, we now have our start. Well, already target's the same. Start is now what? What's our start? 3. Our start is 3, right? It's the same as it was before. And our stop is what? So stop. Mid index from before, so that's 4 now, right? So now we have to find a new mid index. So I'll do it down here. Mid index is 3 plus 4, 7. 5 by 2, 3.5. Lower it down, 3. Our new mid index is 3, and we will key into it, and we'll say, hey, mid index 0, 1, 2, 3. Is 10 equal to 10? Yep. Let's return 3. Pretty cool. Okay, I definitely challenge you later today to write a iterative solution. Go for gold. I'll share this code. Until lunch, you guys are going to be doing whiteboarding. Hang on, I have your pairs somewhere. Where is it? Oh, here it is. I'll make this a little smaller. Oops. Okay, these are your pairs. If you can't find your pair, let me know.